Okay, it seems that we are ready to get going, and so I'd like to start by welcoming everyone to another webinar by JScrambler, this time on the topic of securing content and intellectual property in OTT media delivery. Today, as you might already be able to tell, we'll be looking at these two major business problems for OTT providers, understanding the existing security gaps and which strategies can help minimize this risk. Before we get started, I just want to remind everyone that you'll find a question box right there on your screen that you can use at any time to place your questions. We'll do the Q&A at the end of the webinar, but feel free to use the question box at any time. And don't be afraid of getting technical, because I'm also joined by a colleague from the technical team who will be able to help us with those questions as well. So, moving forward, I want to present our speaker for the day. Joining us is Carlos Rocha Gonçalves, who is the head of marketing and sales at JScrambler. Carlos has an extensive track record working in the software industry, and he works closely with some of the major OTT providers worldwide in helping them improve their application security. Thank you for joining us, Carlos, and feel free to take it away.
Thank you for the introduction, Philip, and appreciate everyone joining us today to discuss this big topic of security in OTT. This is a topic that is actually very interesting for me to talk about, because as Philip mentioned, I get to deal firsthand with the many problems some of the major OTT providers face, especially after the big shift that we have been seeing in the tech landscape. We have a lot of ground to cover today, so I'll get started right away by going through a bit of background about the OTT industry. As I just mentioned, there was a significant shift in technology recently that had a big impact on every OTT provider out there. And I'm talking about the global move from the legacy Adobe Flash Player to newer HTML5 standards when it comes to delivering video on the web. And this is the root of most security challenges that I will be talking about today. But before we get there, I also wanted us to take a quick look at how OTT services came to be. Even before over-the-top services were even a thing, we had decades of history where cable was the only form of premium content available to consumers. Of course, this all changed with the rapid dissemination of broadband internet and growth in web technologies. Because after this, there was a huge opportunity to deliver content over the internet, and this obviously led us to the OTT industry. Today, this is an industry that generates over $100 billion of annual revenue. But of course, getting to this stage required overcoming a series of technological hurdles. But let's go back to the early 90s. A lot of the audience probably remembers this well. The technology was still too immature to provide a reliable video on-demand experience to consumers through the web. And as some providers started to look at this opportunity with interest, they were faced with key business deterrents. The common household didn't have enough bandwidth to support over-the-top media reception. And on the other hand, media compression algorithms were still lagging behind. But then came the late 90s and the beginning of what we may call the OTT era. Technological breakthroughs like DCT compression, ADSL, these completely filled the gap between, on one hand, the average household's bandwidth and the required bandwidth for video content. At this point, the main obstacle for OTT services proliferation was arguably the small number of households with fast enough internet, as well as a 4 decades long monopoly of cable television. So the infrastructure and the market conditions weren't quite there yet. But the internet was quickly reaching more and more households in the US. We know that from 1997 to 2001, the percentage of households with internet access increased from 19 to 50%. Those things were quickly starting to change. As we entered the 2010s, with the increased proliferation of high-speed internet access, we quickly finally reached 4.5 billion internet users, most of which have all the hardware and software needed to instantly stream high quality media over the top. And of course, browsers. Browsers became one of the preferred forms of media playback for consumers. Even today, around 40% of OTT subscribers still use a computer to stream content. And that's still a very significant number of people. This global change is, of course, tied in with the huge growth we saw in recent years behind some SVOD services, and we all know them: Netflix, YouTube, Amazon Video, more recently Disney Plus. And even though almost half of the US households still have a traditional TV subscription, and a lot of people still watching the old TV formats and shows, OTT services are definitely growing fast. Right now we are coming close to 1 billion OTT users globally. And of course, the industry encounters new challenges that need to be faced. First of all, we now see new providers entering the scene in full force and battling for market share with incumbents. So there's no doubt that there's something called customer retention, and that's going to become and will continue to be a top of mind concern. And to retain customers, both these new services and the incumbents are betting not only on exclusive content. That's one way, obviously, to retain the customers, make sure they're satisfied with the content that we're delivering, but they're also betting on technological innovation. And that's actually because if you take a look at some customer behavior analysis, these show that a top reason why users cancel a certain provider is the actual experience of using the video player. And knowing this, providers are focusing more and more on developing disruptive solutions to handle things like buffering, analytics to try to gain more knowledge into the user and how the user behaves, and obviously the user interface. Super important for the experience, and that's what they focus on in an attempt to improve this user experience and, of course, reduce churn, retain the customer. In parallel to this threat of customer churn, we see another top-of-mind concern for OTT providers, and that is piracy. Leaks of premium content have a direct effect both through losses of potential revenue and lack of compliance with content rights owners. And it's curious because there's a relationship here. And I wanted to talk to you about how both these concerns have a common denominator that originates from the actual technology that is employed by OTT providers. And so we reach our main topics for the day. On one hand, the threat of customer churn highlights the value of innovation in intellectual property. On the other, piracy, which is growing, and that directly leads to loss of revenue. Let's start with piracy. From the $9.1 billion it cost the industry back in 2019, piracy is expected to grow to $12.5 billion in 4 years' time. In the US alone, 20% of broadband households are using piracy apps, piracy websites, or jailbroken devices. And over the world, we see an increase of this phenomenon too, especially with the increasing diversity of paid streaming services reaching other geographies. And piracy would be growing much faster if not for the significant breakthroughs in content protection technologies such as digital rights management and watermarking, as I'll explain later on. And here I'd like to zoom into the technology being used by OTT providers so that we understand a common root between these two problems of piracy and customer churn. We already spoke a little bit about this in the introduction, and as most of us will remember, Adobe's Flash Player was the go-to choice for web media playback for almost 20 years. But then HTML5 came and became the new standard, and providers started migrating from Flash to HTML5. They were faced at this point with new opportunities, obviously, but HTML5 also has its own quirks and some security challenges were still there. One of these key challenges was ensuring that only users with the right of access could access the content. And so here I must talk about a major security system that addresses this problem, DRM. Of course, I won't go into much detail about how DRM works, but the gist of it is that it has a series of permission and security checks that basically allow or deny access to encrypted content and obviously the corresponding access keys. So in theory, only rightful users can access this content on their device, be it a browser, a smart TV, a mobile device, you name it. Of course, DRM is still the standard when it comes to tackling piracy in OTT, no doubt about that. But as we know, piracy is still out there and is still growing. Despite DRM being very effective and obviously a best practice in terms of mitigating piracy, it is not flawless. After DRM has verified and decrypted the content, it provides no further protection between the protected player and the display where content is viewed. So this means that when someone gains access to the content, it is extremely difficult to stop this person from capturing that same content. And there are several exploits that do this, such as directly recording from the video, for example, or sound card. And when this happens, this content can be illegally disseminated very easily. And so we find ourselves in need of another security approach that can tackle this issue. And that approach is called forensic watermarking. That's what we're going to talk about next. So forensic watermarking. This is a type of technology that is used to seamlessly embed metadata into digital content in a way that can quickly be retrieved to identify the source of a leak. So what happens is when leaked content is found in the wild, the provider can read its subscriber mark to find the account that started the leak. And from there, it's just a matter of taking down that account to then stop the source of the leak. Seems fairly simple. But here I'd like to talk about why forensic watermarking requires special attention from providers when it comes to security. So modern watermarking solutions are implemented at the client side rather than on the server side. And the need behind this shift was mainly to reduce the latency introduced by that same watermarking, to ensure a smoother user experience, which is obviously vital in this space. And because client-side watermarking has to be applied on the device, it requires additional security measures, namely at the software level. More specifically, the client-side agent that deploys the watermark ends up running on an adversarial environment, meaning that an attacker can use a tool like a browser debugger to access the source code of the agent and tamper with its logic to bypass the watermark. Depending on the watermarking solution, another possibility that I'll show a bit later is tampering with the web page by changing, hiding, or completely removing the watermark. In any case, whatever the approach, the bottom line is that bypassing the agent means that the leaked content will have no watermark at all. And this makes it extremely hard, obviously, for providers to identify and block the source of the leak. And this is why watermarking and OTT providers alike are addressing this threat. Now, I've been talking about piracy for a while now, but we can't forget about the other key concern that I've spoken about, the issue of customer churn. And here I'd like to take one step back so that we understand why JavaScript and HTML5 are a common denominator between both these problems. As I mentioned earlier, OTT providers are developing very disruptive solutions to handle buffering, analytics, user interfaces, always with the overall goal of looking for ways to decrease that customer churn, for ways to improve the overall experience of their users. As you may all know, modern OTT players rely mainly on JavaScript and HTML5, and because of this, we reach the same problem as before when I talked about the watermarking agent. It's JavaScript, so it's a plain text language anyone can read. So code is naturally exposed, meaning that a competitor, for example, can go through the JavaScript or HTML5 source code to understand the logic behind these very unique features and these very unique developments that the providers have invested so much resources on. This obviously means that this is a huge problem when it comes to keeping sensitive algorithms, keeping intellectual property secure. So, both in the case of protecting the watermarking agents and protecting important logic, we need to somehow prevent end users from accessing our JavaScript source code. And I want to now talk about how we can achieve this. Preventing illegitimate access to our JavaScript code may sound like a very similar problem to the one that I explored before about DRM. But JavaScript encryption is completely unfeasible. This is because the browser always needs to interpret JavaScript so that it works. And if we have a decryption key, we need to supply it to the browser. So if that key becomes compromised, all the code will be easily accessed. So since encryption is not an option, the most suitable approach is transforming the JavaScript code for added security. This is actually a security recommendation by OWASP. Some of you may know that organization focused on application security. And it's precisely because of the underlying dangers of exposed JavaScript that there's a recommendation from OWASP to transform it for added security. Typically, one of the first things we want to achieve is to transform the whole of the source code. And we want to turn it into something that is completely unintelligible. But of course, it has to be interpreted by the browser, just like the original code. And the best way to do this is with resilient, first-class JavaScript obfuscation. But what is JavaScript obfuscation? JavaScript obfuscation includes a series of code transformations that basically turn the agent's exposed code into a protected version. And this protected version is extremely hard to understand and to reverse engineer, much like what you can see here in this before and after image. So there's no decryption key at all, but the cost of reversing this transformation is so huge that the attack becomes uneconomical. But while JavaScript obfuscation is a term used broadly to describe the transformation of JavaScript into a form that is hard to understand, the obfuscation results and its actual security depends greatly on the tool or techniques being used. We can talk about, for example, free obfuscators. Free obfuscators offer basic transformations, which may be enough for personal or non-commercial projects, but they can be reversed very easily using automated tools. And even commercial solutions often fail to provide protection that is up to par with what an OTT provider needs. Because this is not just a matter of how effective the obfuscation and the protection features are. We must trust the provider to keep the code clean, safe, and ensure that it will not bring any performance overhead. And of course, performance, very important in this area. And to be able to do all this, this means that the provider has to have dedicated support in implementing the solution, quickly troubleshooting any issues, and of course being compatible with any of the big number of frameworks or libraries you may be using in terms of JavaScript. These points should help you find a solid JavaScript obfuscation solution, but that's just the start. While obfuscation goes a long way to concealing important algorithms, you should consider additional measures on top of it, especially when it comes to preventing attempts to bypass watermarking agents. And you should consider these additional measures because a very relentless attacker may try to understand the logic of our obfuscated code. And he will do this by debugging it and experimenting with it at runtime. His goal will be to gradually understand portions of the agent's code. And here is where most obfuscation tools fail to make the cut. However, JScrambler brings additional security layers to stop the attacker and definitely make his job harder. The most important of these layers is self-defending. This is JScrambler's runtime code protection. And as the name implies, this security layer gives the source code the ability to detect when a browser debugger is open, and then breaks the application immediately if that's the case, preventing dynamic analysis. And not only that, because it also scatters integrity checks throughout the whole protected code, so that whenever a piece of code is changed, even the slightest change, the application also breaks. This prevents, obviously, static analysis and also any attempts of reverse engineering of the protected code. With self-defending as an additional security layer, we basically make it completely unfeasible for attackers to understand or tamper with the code of the watermarking agent. And actually, we can still go one step further. We can make the code trigger an automatic reaction whenever someone attempts to debug the code or tamper with it. By default, you want your application to break as a response to an attack in runtime. But there are several scenarios where it's actually valuable to trigger other types of countermeasures. An example is, for example, redirecting attackers to another page. If you are able to do that, you can make them lose any progress that they had already made in your page. Another valuable action would be to issue a custom callback to your scene. This way, you would be able to send an immediate alert to your security team that something is wrong. And of course, more advanced countermeasures like real-time notifications can also give you increased visibility over any attempt to debug or tamper with your code. And speaking of this topic of real-time notifications and increased visibility, I must talk about another common tactic used by attackers to exploit watermarking techniques. I didn't mention this earlier, but forensic watermarks are imperceptible to the human eye. So, considering that fact alone, we could argue that it's more difficult for attackers to understand when forensic watermarking is actually being used. That is not to say that cautious attackers will not check this thoroughly. By taking a look at the DOM, document object model, in some cases they may understand which parts correspond to the watermark. Then it's just a matter of modifying or removing these parts to strip the watermark, capture the content, and then distribute it on piracy platforms as freely as they want. So besides protecting the JavaScript source code of the watermarking agent, a watermarking solution may include some sort of protection against attempts to tamper with the DOM to remove the watermark. One way to achieve this is by employing a web page monitoring solution. JScrambler's web page integrity module does this by detecting any type of DOM tampering in real time. As a result, if the attackers try to change or remove some types of watermarking, web page integrity displays a real-time alert to the OTT provider and allows them to block the attack. Looking back at all the security strategies that I've presented today, we can see that it's the combination of these strategies, and not a single strategy alone, that enables reducing exposure to piracy and IP theft. Combination of DRM, client-side watermarking, resilient JavaScript protection, and even web page monitoring means having a highly performant OTT platform that is equipped for the piracy battle and that is able to keep algorithms secure, and of course extending the actual lifespan of a competitive edge. And I think now is probably the perfect time for me to show you a demonstration of these attacks and how JavaScript protection and web page monitoring prevent them. So here we are in our demo of an OTT video platform. The version that we are seeing now is your run-of-the-mill web application where the underlying JavaScript and HTML5 code are not protected in any way. Let's assume that I'm not just any regular end user. Let's say that I'm actually a competitor trying to snoop around for any interesting code logic that is running on the video player. I just have to open any available content here. And now that I'm on the player's page, I can just pop open the browser debugger. Let's say that I know that this provider has some very interesting logic for handling video buffering and the progress bar, and I want to copy it. I just go to the source tab and then to JavaScript, and I quickly find the JavaScript source code of the player. I can now just do a quick search for anything related to buffering. And that takes me to the logic that's behind this progress bar. By digging around a little further, I can potentially uncover some interesting algorithms, and then it's just a matter of time before this somehow gets replicated. Now, let me change from the shoes of a competitor to those of an attacker. When I reach this video player, my goal is to be able to capture the video and leak it. I see that the platform is using a watermark. And let me just make a note here that this watermark is visible just to make it easier to demonstrate these next steps. In a real world scenario, the watermark would likely be invisible. Right, back to my attacker persona. My goal is to remove this watermark so that I can leak the video without any traceability. Let's see if I can tamper with the code of the watermarking agent so that I can bypass it. I open the browser debugger and inspect the watermark, and I find it almost immediately. Now I move over to the sources tab, and then under JavaScript I have a watermarking.js file which I see contains the source code of the watermarking agent. Now I can go through this logic and mess with it to bypass the watermark. I'll go ahead and add a breakpoint here. Refresh the page, and then I can simply change the behavior of a function so the watermark is never actually placed on the video. And if I close the debugger and play the video, the watermark is gone and I'm free to capture the video with no traceability. Of course, in reality, this could be somewhat more complex, but the reasoning remains the same. Even if this agent communicated with the backend, we could still see its client-side logic and tamper with it to bypass the watermark. Now, as I mentioned before, there's another route I can take. Instead of trying to tamper with the watermarking agent, I can try to simply remove the portion of the code that contains the watermark itself. And now I open the debugger again. By replicating my previous steps, I see that there's a div here that contains the watermark. Let me just go ahead and delete it. Now the watermark is gone and I'm free to capture and leak the content, knowing that the provider likely has no way of tracking it all the way back to me. Now, let's change tracks for a bit and look at a more positive scenario. What would happen if this JavaScript was actually protected? And to answer that question, let me jump out of the attacker's shoes and into the shoes of one of the developers from the OTT provider's team. If I'm one of the developers, I will assume that I have the whole original source code, obviously, of both the web player and the watermarking agent. I will enter the JScrambler virtual appliance that I'm running on my company's infrastructure and where I already have placed the source code, as we can see here on the left side of my screen. And by clicking on each file, I can preview their source code in the middle of the screen. We don't have any protected code on the right half just yet, but we'll see that in a second. On the right side of the screen is exactly where the magic will happen. Here, I can go to the Templates tab to browse and select one of the predefined protection templates that are already provided by JScrambler. And what are these? These are a combination of pre-selected transformations that I can apply to protect my source code with a specific goal in mind. In this case, I want to protect both the web player and the watermarking agent against debugging, tampering, and obviously reverse engineering. So therefore, I will select the self-defending template. But I still want to tweak things a bit. So I'll move over to the fine-tuning tab here. And this is where I can customize my protection and also instrument how my app will react when someone tries to tamper with the code. I scroll down to this countermeasures section here and I'll go ahead and select real-time notifications. With this, I will be able to receive a notification whenever tampering or debugging are detected. And I also want to add a domain lock to prevent someone from copying the source code and running it somewhere else. So On this code log section, I select domain lock and I write my whitelisted domain. There you go. As countermeasures for this lock, I also want to select real-time notifications. Now, I just need to apply all of this to my source code, right? So I click Protect App, and I get the new version of my code here on the right side of the screen. There you go. Quick and easy. Another thing I wanted to mention here is that developers have the option of interjecting diversity into each protected build. This means that it will yield a different output every time I click Protect App, so every time I protect it. And what this polymorphism mechanism achieves is increasing the security posture of my applications in production even further. Since you can have multiple different versions of the same protected code, and that obviously makes the pirate's life way more difficult. And I know that the code looks like garbage code, but the beauty of it is that once compiled, this application will still run on our OTT platform, just like it did with the original code, with no changes whatsoever to its functionality. And you don't have to take my word for it. Let's prove that that's the case. Let's run this protected version and I'll go back to my persona of one of the OTT provider's competitors to try to replicate the attacks that we saw earlier. So I'm seeing exactly the same screen now, and now I'll again open one of these videos here. Like before, I want to uncover the code that is handling the buffering and the progress bar, just like we did earlier. So let me try to check the source code again by using the browser debugger. Well, right off the bat, the player has stopped working, as you can see, and I can try to get it to resume. But I'm always stuck on the debugger loop. So it seems I won't be able to use the player at all with the debugger open. And this is happening because of the anti-debugging layer that JScrambler added to the source code. Let's see if I can still get to the source code. By going to the sources tab, I quickly find the JavaScript source code of the player again. Okay, it seems that I can see some information here. Let me just print the code, and here is the code. But I can't really make much sense of it because it has been highly obfuscated. So what I'll do instead is select some random breakpoints to perform a step-by-step inspection. But just as I do that, I see the call stack growing and I'm again stuck in an infinite loop. So this is once more a result of JScrambler's anti-debugging feature. A good thing is that if I close the debugger, the application saved state is easily resumed. So this prevents a drastic action in case the debugger was, for example, accidentally opened by a legitimate client. Another similar scenario here is if I just wanted to create a copycat player. To achieve that, in theory, I don't even need to understand the source code of the player. I can just retrieve it and deploy it in my own domain. After doing that, I can open my copycat platform, which is, as we can see right here, is running on a different domain. Now I just have to open one of these movies and then the player won't work at all. What happened here was that the domain lock that we added before was activated, preventing the code from running on a disallowed domain. So it simply does not run at all. So now that we have covered the intellectual property theft scenario, let's move on onto our second scenario, where I'm trying to leak content. To recap, my main goal is removing the watermark before leaking the content. So let me just move over to our original player here. And again, my first step is opening the debugger. Just like before, JScrambler paused the player, and now I'll go ahead and inspect the logic behind the watermark. After pre-printing the code, I can see that it is also highly obfuscated. So I can't really find any obvious logic that points me towards what I'm after. We already know that adding breakpoints won't work because of JScramblers anti-debugging, but I'm a determined attacker. So for my next step, I'm going to statically analyze the code and try to reverse engineer it. And to do that, I've got the complete source code here locally in a text editor. And even though this doesn't even seem like recognizable JavaScript, I'm going to try to reverse engineer it. And what I can do is try to discover a function here, such as, for example, eval. And I do in fact see an eval function here. So I could make an assumption that whatever variable is being fed to the eval, it will probably take me to the original code. So to do that, what I'll do is try to console log the content of this variable. And then let's save the code and run the app again. So as you can see, the player simply breaks. And this happens because of the JScrambler anti-tampering feature. When the application developer protected the app, what JScrambler did was to scatter integrity checks throughout the code so that it can detect if its original functionality has been tampered with. And since the player didn't even start, I can again open the debugger and check what was dumped to the console. But all we get is trash and broken references. So there's nothing more we can really do from here. So this basically means I failed to debug the app at runtime and even to change the code statically to reverse engineer it. So no matter how I try to tamper with this code, it keeps me locked out and makes me lose all progress whenever I seem to gain some ground. Since that got me nowhere, I still have the option of just outright removing the watermark after it is placed on the player, which is something that will probably work with some watermarking solutions out there. So I'll open our protected player again. And after opening the browser debugger, I'll just go ahead and inspect this element. This will take me to the div that contains the watermark. I can just remove it and that's it. This, in theory, will allow me to move on to capturing the video without a watermark. But let me now pause this attack to show you what has been going on the side of the OTT provider. More specifically, let's take a look at the JScrambler dashboard that the provider is using. When they log into their JScrambler dashboard, they will see this app live feed, basically listing all of the attacker's attempts to tamper with the code. And looking at the alerts for code integrity, we see an alert for a debugger that was opened and also that the self-defending capabilities were triggered. This happened before I was trying to debug the source code. I can also see an alert here for a domain lock. If you recall, this was triggered when I tried to run the protected player on a copycat platform. And then we also have alerts for a tampering attempt, which happened when we tried to modify the protected source code and run a tampered version. So all of these notifications appear in the JScramble dashboard because we activated a countermeasure called real-time notifications when we protected the source code earlier. And this is the result. So basically for each attempt to debug or tamper with the platform, the OTT provider is able to receive a notification with relevant details such as the IP address of the attacker and the user agent. And this gives them a way to better understand how attackers are trying to tamper with their app and eventually adjust their tactics to further increase security. When we move on to the web page integrity notifications, we see that someone removed the div that contained our watermark. This is outright malicious behavior, so we can jump right in and check the user session that generated this report. By cross-checking this with then our user database, we can immediately block the account that is doing this. And because these notifications happen in real time, we can block the account within seconds of the watermark being removed. And so let's just take a second to see how this can be extremely valuable in conjunction with watermarking. if the attacker couldn't find a way to remove the watermark, the leaked content would have the metadata required to take down the origin of the leak. And on the other hand, if the attacker tried to remove the watermark, web page integrity detected this in real time and the account would be taken down in seconds. In either case, the source of the leak was contained and we took incisive action to minimize our exposure to piracy. So I guess we can safely say that we will be able to defeat the pirates. So I think this is a good place to stop the demonstration section and move on to some final takeaways. And yeah, we covered a lot of ground today. Right at the beginning, we saw how new web technologies have prompted an incredible growth in OTT services, namely with the HTML5 standard. And then we also discussed how with so many providers entering the scene, customer retention is more and more vital. And because of that, OTT providers must make sure that client-side JavaScript and HTML5 are protected and cannot be retrieved by competitors. As for the growing threat of piracy, the industry is deploying security systems such as DRM and watermarking. We also covered that. And we saw that client-side watermarking has great performance benefits. But at the same time, it also requires additional protection against client-side exploits. And we explored some of those, such as code tampering and DOM tampering. This means that JavaScript source code of the watermarking agent must be protected against bypassing attempts. And so this protection must go beyond obfuscation to include anti-tampering and anti-debugging layers. And not only that, but there must be a security system in place that is capable of detecting any attempt to remove the watermark from the DOM, while at the same time enabling providers to take down the offender's accounts. We also showed you how JScrambler provides both these levels of protection, protecting JavaScript and HTML5 with the most advanced set of layers, while also monitoring web pages in real time to detect attempts to remove watermarks. And so enabling providers to quickly block these affected accounts. I'll finish with saying that JScrambler has a track record of securing platforms of some of the biggest OTT providers out there. And like I told you in the beginning, I know and I get to experience firsthand that the support provided by JScrambler's team of experts allows a very quick and very seamless deployment of both solutions. And I guess that's it from my side. Thank you very much.